Madam,
Yeah.
am I audible?
Yeah. Thanks. Yeah,
Oh,
that's
okay.
great.
Thank you, one and all. It's a privilege to be a part of the eminent researchers in the field. I'd like to go back to the presentation topic. The topic of the presentation is predicted HbA1c and fructosaminated HbA1c, evaluating their role as an indicator of glycemic status in diabetes mellitus. Let me first introduce you to the topic and the rationale of picking this topic. Now, diabetes mellitus is a lifestyle disease and is increasing by leaps and bounds all over the world. Now, when we speak of diabetes mellitus, it has got significant mortality and morbidity. So when you speak of our country, India, the number is very high and quite high in respect to many other countries, such that every fifth Indian is a diabetic. So it is very pertinent and very important to take a look at the disease and also take a look at what level we can check with the complications associated with it. So when we say diabetes mellitus, uh, the first thing which comes to the mind is a long-standing period of glycemia, which can be controlled or uncontrolled, finally leading on to the complications. Now, complications can be microvascular, complications can be macrovascular. So all of them finally leading on to significant mortality and morbidity. So this, as I started with the topic, so what becomes very important is to know the glycemic status indicators, which will help us in tracing the process. Now, if we look at the present day, what is the glycemic status indicators which we are having? It is HbA1c. It is HbA1c. That is glycated hemoglobin, which is perhaps the most popular glycemic status indicator which we are following. Now, when we speak of HbA1c or glycated hemoglobin, it is basically the glycation which occurs in hemoglobin, and we know that hemoglobin is present within the RBCs, and then we extrapolate it to the whole section of proteins in the individual. So basically HbA1c or glycated hemoglobin, when you speak of, is a intracellular glycation because hemoglobin is present within the RBCs. Now, do we have any other glycemic status indicator? Yes, although less popular, but we still have. We have another glycemic status indicator, which is fructosamine. Now, that is basically glycated albumin. So when you speak of fructosamine or glycated albumin, that is the glycation of albumin, which is detected by various methods. Now, when we speak of glycated albumin, that is a process which is extracellular glycation. So when we speak of the glycemic status indicator, either we take the HbA1c, which is basically a intracellular glycation marker, and we extrapolate it to the whole individuals, or in some cases we take fructosamine, but of course it is less popular because it is a half-life of around 3 weeks. So we take fructosamine, but that is exclusively a extracellular glycation marker, and we extrapolate it to the whole individual. So when we look at the complications of diabetes mellitus, either macrovascular or microvascular, it basically involves through the formation of advanced glycation end products, AGEs. And what are AGEs? They are basically dominantly the extracellular proteins which are involved. So if we have a marker which can actually predict both the intracellular glycation and extracellular glycation, that will be perhaps an ideal glycation marker. And that's why we have taken the topic and we have focused on to the fructosaminated HbA1c. So basically it's a combination of both HbA1c and fructosamine, which is fructosaminated HbA1c, and that's why the significance of the topic. So in our paper, these were the aims and objectives to evaluate predicted HbA1c and fructosaminated HbA1c in the study groups, to correlate the values of predicted HbA1c and fructosaminated HbA1c with the average fasting blood glucose, and assess whether the parameters can be used as a reliable indicator of glycemic status. Now, regarding the materials and methods, the present cross-sectional study was carried out in the Department of Biochemistry, All India Institute of Medical Sciences, Mangalgiri, Andhra Pradesh, India, and was a part of the ICMR study. 50 cases of diabetes mellitus diagnosed as per the guidelines laid down by American Diabetic Association were selected, such that their blood glucose levels do not show more than 20% variation assessed 30 days apart. So only the average of the two fasting blood glucose levels were taken. To avoid any influence on fructosamine measurement, only cases with normal total serum protein and albumin levels were taken, that is, which where protein and albumin levels were in the standard reference range only. Detailed history, physical examination were done for all the participants involved. 50 age and sex matched controls were also taken for the study. The samples were collected after informed consent, and they were all done with the proper IEC approval, Institutional Ethical Committee approval, done under this period. So these were, as I said, these were the inclusion criteria. Difference between the two values of blood glucose level is less than 20% over 1 month, and serum protein and albumin in the standard reference range, because we were taking fructosamine, which is basically glycated albumin. These were the exclusion criteria: liver diseases, proteinuria, hemoglobinopathies, erythrocyte disorders, recent history of blood transfusion or blood loss. Now coming on to our results and observation. We used, for analysis, we used the SPSS software version 21. We checked with the normality of data by the popular methods, and we found that the data was parametric, and then subsequent analysis was done. Now, analysis is done as mean and standard deviation first. So when I am showing the mean and standard deviation, we are getting the values of predicted HbA1c and fructosaminated HbA1c. So let me first go on to how we got on to predicted and fructosaminated HbA1c, which are the stars of our study. Now, if you look at the two scatter plots which are displayed in the slide, let me first go to the second scatter plot which is displayed. Now, this is a scatter plot which represents HbA1c in the y-axis and fasting blood glucose in the x-axis. Now, we got a regression equation. Now, with this, basically, a regression equation of HbA1c termed predicted HbA1c was plotted on fasting blood glucose. As you can see, it was in the x-axis on fasting blood glucose derived from the data of study group involved in the study. So finally, we got y is equal to 3.37 plus 0.03 into x, and x is the value of fasting blood glucose. So for each value of fasting blood glucose, we got y, that is predicted HbA1c. Similarly, for fructosaminated HbA1c, the scatter plot was drawn with HbA1c on y-axis and fructosamine on x-axis. Now, the regression equation we got finally y is equal to 3.15 plus 0.01 into x, such that for each value of fructosamine, which was calculated in micromoles per liter, for each value of fructosamine, we got y, that is fructosaminated HbA1c. So that is how we calculated both predicted HbA1c and fructosaminated HbA1c. That is fructosaminated HbA1c. Again, as I repeat, it's a regression equation of HbA1c, which was plotted on fructosamine derived from the data of study group involved in the study. So this is how we got fructosaminated and predicted HbA1c, and then the standard parameters were compared for their mean values. So if we can have a look in the mean values in cases and controls, we find that similar to the standard glycemia indicators like HbA1c and also to the other evaluators, fructosaminated HbA1c and predicted HbA1c showed significant difference in the controls and cases. The average value of fructosaminated HbA1c was 5.21 plus minus 0.26. And for predicted HbA1c, and same in control in cases, it was 6.72 plus minus 0.92. Similarly, is the value for predicted HbA1c nearby, and there is a significant difference between the two groups, that is controls and cases. Now, going on to the correlation analysis of glycemic indices. So we got the value of fructosaminated HbA1c and predicted HbA1c. So we thought, let us correlate it with the standard glycemic indicators, that is HbA1c, and also to an extent fasting blood glucose. And we found that it showed a significantly good correlation between those parameters, right? So with HbA1c it was 0.761, and with fasting blood glucose 0.751, although the rest were higher. But the correlation, but the logical explanation, we with the purpose with which we went and we have gone with the study, so it has also a very high correlation value. So next we thought, let us go on to the ROC curve, that is receiver operating curve of the glycemic indices, so as to establish two things. Number one, to find out a value at a certain cutoff level, which we got at around 5.85% for fructosaminated HbA1c, where the test is 88.2% sensitive and 100% specific for diabetes mellitus. So at a cutoff level of 5.85% of fructosaminated HbA1c, the test is equally very good, very high sensitivity and quite specific, 100% specific. And the area under curve was also very high, in line with the standard parameters, that is HbA1c and predicted HbA1c. That is, the area came as 98.6%, whereas the same for fructosaminated HbA1c, it was 96.8%, whereas the same for A1c and predicted HbA1c was 98.6% and 98.7%. So what I mean to say is, basically it is also, the area under curve is also in line with A1c and predicted HbA1c. So we propose this as one of the parameters, going by the logical understanding that it can represent both intracellular and extracellular glycation together. So this can serve perhaps a very important connection between the glycemic status and the long-standing implications or complications of diabetes mellitus, so that we hope this might play a role in predicting those cases which might go on to the complications early or complications late. So this was the overall study. We find that fructosaminated HbA1c is significantly increased in diabetes mellitus. It is highly correlated with the glycemic indices and has a decent, that is 96.8% area under curve on plotting of ROC. So we suggest that it can be used as a part of glycometabolic profile and can provide insight into the glycation tendency of the individual. Of course, the future prospects or future scope of expansion of this parameter remains. A future study to exhibit the association of these parameters with microvasculature and macrovascular complications of diabetes mellitus is suggested to exhibit wider acceptance. Perhaps this can be one of the eye openers or players which can help us to unravel the mystery of glycemia and imminent complications of diabetes mellitus, so that we can take the precautions accordingly and early. These were the references through which I have drawn the study. Thank you so much for the patient listening. I am open to any of questions.